Hello everyone. Welcome to another video of Introduction to Programming. So far in this module we have talked about what is programming, the machine language, binary, as well as what is character encoding. Now let's talk about how the program and programming works. And we will also talk about what's the relationship between the program that we wrote and the machine language. So, programming, first of all. Programming means it is talking to a computer or to a digital system, right? And we already have learned that the CPU is the key player to process the machine language to give the output at the end. So once we have the binary code, the CPU will be able to process it and give us the output. Remember, the CPU is made up of lots of transistors. Those transistors, they can only process the binary codes. So once we have the binary code, the CPU will be able to give us the output. Okay. And the transistors of the CPU can only process the codes that are written in the binary code. Okay, which is the lowest level of language. The machine language is the lowest level of language. And we just learned that we will be writing our codes in the high level language. Why? Because high level languages are easier for us to learn and easier to read, and it is more understandable. Where the machine language in the other hand, it is much more difficult for us to learn, read, and understand. Okay? So now the question is, how our code in a high level programming language can be converted to binary code like this. Okay? So when we write our codes, we use a language. High level language can be like Java, Python, Ruby, or JavaScript, or C++. Those are also known as the high level programming language because they are more closer to the human language. Okay? So after I wrote my source codes, how can I make sure that my source code can be translated into the binary code? Because computer can only understand the binary code. CPU can only process the binary code. So how can we make sure that our source code that we wrote by using a programming language can be translated into the binary code? For that, we will need to use compiler or the interpreter, or both of them. You need to have at least one of them or both of them. If the programming language is an interpreted programming language, that means it can be translated into the binary code. And if the programming language is compiled programming language, the compiler can still translate the source code into the binary code so that you can get the output at the end. And what does it mean by interpreter and compiler? So we just stated that we need either interpreter or compiler or both of them to be able to run our program, to be able to translate these source codes into the binary code so that the computer can understand, right? So what does it mean by interpreter? Well, an interpreter, it is basically a program that reads the source code that you wrote. Doesn't matter if the source code is from the Java or Python. The interpreter will read it. Okay? It reads it line by line. When you write your source code, if the programming language that you are using is interpreted programming language, it reads it line by line. And then each line will be translated into the binary code one by one. And after each line is translated to the binary code one by one, then line by line, those binary codes will be directly sent to the CPU. They will be directly sent to CPU to process. And the processing will be done during the runtime. So that is what kind of program this interpreter is. Okay? And we have the programming language like Python, Ruby, JavaScript. that are known as the interpreted programming language. Okay. So what makes this interpreted programming language different than the other compiled programming languages? That uh, it the those steps of converting the source code into the binary codes are done during the runtime. When you run it, while the application is running, then the source code can be translated into the bytecode and be sent to the CPU to process it. Okay, so that is what interpreter is. And the compiler, in the other hand, so compiler, it is a little different than interpreter. Okay, a compiler, it is basically a tool. This tool, it still translates the source code, but it does not translate it like line by line like the interpreter does. Okay, it translates the entire source code of the program. Okay, when it translates the entire source code of the program, it will create a form. Then the form, which contains all the binary binary codes, will be directly executed by the computer's hardware. Or it can also be executed by a virtual machine, just in case if there's a virtual machine that is installed together with the software of a program. So as long as the form is created by the compiler, then this form can be directly executed, either by your computer's hardware or by the virtual machine that has been downloaded. Okay. So this the reason that it is called a compiler is because those steps of converting the binary code to the source codes are done during the compile time. Okay, you don't have to execute it in order to get the binary code result. During the compile time, before you are running the application, you will already have the binary code, and binary codes will be in the form. The form will be executed by the machine that you have directly. So as for the compiled programming language, we have C++, C, and Go. Okay, those languages are known as the compiled programming language, and they are often used for high performance applications. Okay, the performance is much more faster with the compiled programming language. And the advantage of interpreted language is it is much more easier to code compared to the compiled programming language. Okay, so these are the difference between interpreter and compiler. So the programming language will use either interpreter or compiler or both. Okay, there are also some programming language that uses both the compiler and interpreter. Okay, and that this approach that uses both compiler and interpreter is known as the hybrid approach. Okay, so those language examples that we stated here, they are not using the hybrid approach because Python, Ruby, JavaScript, they are only using the interpreter, not the compiler. And as for the C++, C, and Go, they only use compiler, not the interpreter. Okay, that's how those languages translates the source code and then into the binary codes. Once the binary codes are ready, then it can be executed. Then the CPU can process them. Okay, and some other language, they do use both interpreter and the compiler. The ones that are using the hybrid approach. So what is this hybrid approach then? Well, hybrid approach are basically the combination of both compiled and interpreted language. Okay, this gives the programming language the best of those two, best of both interpreter and compiler. Both of them, they have their own advantages, right? So what happens when the programming language uses this hybrid approach? Well, the programming language will become fast, just like the compiled programming language. Okay, the language that are using hybrid approach will be as fast as the compiled programming language like C++, C. Okay, And since this hybrid approach also involves using the interpreter, then the benefit of interpreter, it is going to be easy to write and easy to debug. Okay. So when if the programming language is using the hybrid approach, those are the benefits that the programming language will have. Fast like the compiled language, and easy to write and debug like the interpreted language. Some examples of the hybrid language, it includes the Java. Java is now well-known hybrid language. Okay. And besides Java, we also have C#. Okay, known as the hybrid language. So far in this module, we have talked about the programming, machine language, binary, and also the base 2 system, base 10 system, okay, as well as character encoding and how programming works. So here are a few takeaways from this module. So from this module, after completing this module, you should know that a program is a set of instruction that tells the compiler what to do. That's what program is. And programming languages are the ones that are used to write the programs. If you wanna write programs, you need to use one of those programming language, not the machine language, because machine language is much more complex. Even though it's the only language that the computer understands, but it is hard for us to learn, read, and write. Okay, and machine language they uses binary codes, which is made of zeros and ones. Those zeros and ones they define two states: the state that is on and off. Okay. And every piece of data in your computer, it's represented in a binary code. Doesn't matter if the data is number or character, whatever it is represented in the binary code, so that the CPU can process it. Okay, and the Java that you are about to learn, it uses the UTF-16 character encoding scheme. It is used internally in Java. Okay. And Java uses hybrid approach to convert its source code into the binary code. So make sure that you know what this hybrid approach is, and make sure you also know the difference between interpreted language and compiled language. Thank you so much, everyone. I will see you all in the next module.